All right, so now we're going to talk about the law of cosines, which is 6.6, and this is another way to solve oblique or triangles that are not right triangles, depending on what scenario you're given. For this case, for the law of cosines, you'll use the law of cosines if you're given two sides and an angle, but notice that the angle is included between the two sides. And what I mean by that is, if you've got a triangle, right, you've got a side here, this angle is the one between that. That's the included angle. All right, so we're given side, angle, side, or if we're given three sides, we use the law of cosines. So the law of cosines comes from the distance formula, and it's complicated. I'm not going to write it all out and prove it, but you just need to know that there's a pattern here. You can figure out the pattern. You need to know the law of cosines. So the one I've written is a squared equals b squared plus c squared minus 2 times bc times the cosine of a. All right, so if I had b squared, it would equal the other two sides squared, so we would have a squared plus c squared minus 2 times those two sides times the cosine of b, that angle. All right, c squared would be a squared plus b squared minus 2ab cosine c. All right, so this is the law of cosines. Depending on what you need to find is which one you use. All right, so let's look at some examples of this. So my first example here, I've already got the triangle labeled and drawn out. I'm given side B, I'm given side C, and I'm given the angle included between those two. A is between 15 and 18. So this is side, angle, side, so I'm using the law of cosines. In this particular example, they just want me to find side A. All right, so if I'm finding side A, I need to know a squared equals b squared, which is 15, squared plus c squared, which is 18, squared minus 2 times b times c times the cosine of a, which is 108 in this case. So really setting this up, if you know the formula, that's not the difficult part. Probably the most difficult part of this is just doing the algebra, solving this, making sure that you enter it in your calculator and don't make a careless mistake. All right, so what I would do here is I would subtract the 15 squared and the 16. Like this is, you don't have to subtract that. I don't know what I'm talking about. We're isolating a squared. It's already isolated, so all we need to do is just go straight into our calculator here. You might want to make sure that all this is in parentheses just to be careful, and so go ahead and get your calculator out and practice that when you enter this in. And we're going to get a squared is approximately 715.9, which means I need to take the square root of that to isolate a, to get a by itself. And so a is going to be approximately 26.8, and that's what I was looking for. All right, let's do another example. In this next example, I'm given three sides, so I'm going to label that. I've got 122.5, I've got 60.1, and I've got 154.6, and it asks me to find angle C. All right, if I'm finding angle C, I've got to do that c squared equals, right? So the other two sides. So I've got c squared, which is 154.6. Let me write it out. So we've got c squared equals a squared plus b squared minus 2ab times the cosine of c. is what I'm looking for here. All right, so I've got 154.6 squared equals a squared 122.5 squared plus b squared, or 60.1 squared, minus 2 times 122.5 times 60.1 times the cosine of c. All right, then this is what I was starting to talk about in that last one, and anyway, all right, we're isolating cosine of c, so let's go through that. I know these numbers are big and they're kind of a pain, but you have a calculator, so just rely on that for these numbers. So the first thing I'm going to do is subtract 122.5 squared and 60.1 squared. I'm going to take that to the other side. That's why I'm subtracting. So I've got 154.6 squared minus 122.5 squared minus 60.1 squared. All right, when you plug that in your calculator, you get 50 to 82.9, and I hope you're plugging this in your calculator. Pause the video if you need to and make sure you're getting these numbers. All right, so minus 2, I'm going to leave this. I'm not going to try to do it all in one step because I want you to see the process. Times the cosine of c. All right, I'm still isolating the cosine of c, so I'm going to divide all this by negative 2 times 122.5 times 60.1. Now, this is going to be very important. When you divide all this, you have to put this in parentheses. Because if you don't put it in parentheses, what's going to happen is it's going to be 5282.9 divided by negative 2. And then when you go times, it's going to start multiplying all that out. So make sure you put that in parentheses. So do 5282.9 divided by parentheses negative 2 times 122.5 times 60.1. Close your parentheses. That's isolating. That's giving me the cosine of c, which is approximately negative 3.588. What am I going to have to use to find the angle? I'm going to have to use the inverse function. So I've got the inverse function of negative 0.3588. When you plug that in your calculator, our angle here is approximately 1111 degrees. Okay, and just checking that. And that's going to be your biggest side because that's your biggest angle and it's an obtuse angle. All right, let's go on. I'm going to do one more because this is not just asking for one unknown. This is actually telling me to solve the triangle. So this is going to, I've got to get all three sides, all three angles. In this one, they give me all three sides. So I'm using the law of cosines. I recognize that. I've got to find all three of my angles. All right, so I'm going to find angle C first. All right, if I'm finding angle C first, that means that C squared equals A squared plus B squared minus 2 AB times the cosine of C. All right, same process we just did. We're going to subtract 40 squared, subtract 12 squared from 44 squared. Then we're going to divide all that by negative 2 times 40 times 12. And when we get all that, we're going to take the inverse of that. And when we take the inverse of that, should I write it out for you? 42 44 squared minus 40 squared minus 12 squared, all divided by negative 2 times 40 times 12. That equals the cosine of c. So we take the inverse of all that, right? And we're going to get c to be approximately 101.5. All right, so here's the next question. We've got 3 sides that were given. We've found 1 angle. So I still have to find 2 more angles. How are we going to do that? Well, we can use the law of cosines again, but at this point, I could also use the law of sines, because now I've got a ratio that I could set up with my c's and then find either a or b. So let's do that. Like I said, you can use the law of cosines, but you probably find the law of sines a little bit easier to deal with. So let's do that. So we're going to do the sine of 101.5 over 44, and it doesn't matter if we find a or b first, is going to equal the sine of a over 40, right? That's one of our proportions. To find b, we would do the exact same thing using b. So we've got the sine of b over 12. We already know how to do this. This is cross multiplying, isolating, using the inverse function. And so a is approximately 63 degrees and b is approximately 15.5 degrees. Okay? And the only thing that I want to make a note of here is that when you're given 3 sides of a triangle, you know you have to use the law of cosines to solve that for the first angle. All right, we chose to use the law of sines to find the other 2 angles. Remember that the law of sines has ambiguity, which means there's an ambiguous case involved. To avoid that, we want to avoid that. To avoid that, find the biggest angle first. All right, because the law of cosines doesn't have ambiguity. So if you find the biggest angle first, I found C first. It was an obtuse angle, but I know it's my biggest angle, and so the other 2 angles have to be acute. So there's not going to be, if you use the law of sines after that, there's not going to be any ambiguity. All right, so let's write that down just so you make a note. So if using the law of sines after finding the first angle, using the law of cosines, all right, this is the important part. Make sure to find the largest angle first. So no ambiguity. All right, and you know how to find the biggest side first. The largest angle is always going to be across from the largest side, so make sure you do that.